Hello boys and girls, this is Dr. Lee. Welcome to the series of Math Olympiad for Primary School. For today, we'll focus on 5 questions on numbers and operation from the National Mathematical Olympiad of Singapore, NMOS 2022. Let's begin with one simple question. Evaluate 11 times 20.22 plus 150 times 0.2022 plus 2.1 times 202.2 plus 0.03 times 2022. Notice something interesting here. All the numbers we are multiplying with seem to be related. They are all versions of the number 2022 but with the decimal point shifted. This suggests a common factor could be used. Let's start by breaking it down. We can write each term by factoring out common factor of 20.22. Hence, 11 times 20.22 is simply 11 multiplied by 20.22. 150 times 0.2022 can be written as 15 times 20.22. 2.1 times 202.2 is 21 times 20.22. Finally, 0.03 times 2022 simplified to 3 times 20.22. Now, we can sum this up by adding the coefficient we found. 11, 15, 21, and 3. We get a sum of the coefficient as 50. So, the answer is simply 50 times 20.22, which gives 1011. And this is the end of the discussion for this question. For the next question, P and Q are two prime numbers. Given that 3P plus 5Q equals 1 to 1 and P plus Q is a perfect square, we are asked to find the value of Q minus P. Before we jump into calculations, let's establish a key observation about prime numbers. Apart from the number 2, all other prime numbers are odd. Since we are dealing with two prime numbers, it means if one of them has to be even, then it must be 2. This is a critical insight for our next steps. Since 1 to 1, 3 and 5 are all odd numbers, one of the P and Q must be even. As mentioned, either P equals 2 or Q equals 2. Assuming P equals 2, and plug it into 3P plus 5Q equals 1 to 1. We solve to find Q's equals 23, a prime number. Adding P and Q gives us 25, which is 5 squared, a perfect square. This confirms our assumption is valid and P plus Q is a perfect square as given by the problem. If we consider the case where Q equals 2, then P will be 37 after solving 3P plus 5Q equals 1 to 1. However, P plus Q is 39, not a perfect square. So this option is out. With P as 2 and Q as 23, the difference Q minus P is simply 23 minus 2, which is 21. Problem solved.